Good morning students. Today we are going to learn about the topic is hydraulic press. Okay. So the Pascal law have some application. One of the application is hydraulic press. What is Pascal law? The external pressure applied an incompressible liquid is transmitted uniformly throughout the liquid. Okay. So the hydraulic press is a machine. If you apply small force, it acts the heavier force. Okay. So it is used to the mechanical shop. If you lift the two-wheeler, we use the hydraulic press. So the hydraulic press consists of two cylinders of different cross section. Listen, the piston. So the piston is fitted with the cylinder. It compresses the liquid. Okay. So this is the small cross section area. Then we see the another piston here. It have the large cross section area. Now listen carefully. The small piston area cross section is A1. The large piston area cross section is A2. Okay. Now you apply the force on the small cross section area. So here listen, this is the object. Okay. So the object is placed on the large cross section area. This is the hydraulic system. Okay. Now listen, F1 force. F1 is the force to be applied over the small piston of area cross section A1. Okay. So here listen, the object. The object to be lifted to the placed over the piston is A2. Now you apply the force F1. So here the pressure is produced. What is pressure? Force acting on the unit area is pressure. Okay, what is pressure? Force acting on the unit area is pressure. You apply the Pascal law. What is Pascal law? The external pressure applied on incompressible liquid is transmitted uniformly throughout the liquid in all direction. Okay. Here now you apply the force F1. Here the pressure is uniformly transmitted. The pressure is uniformly transmitted. So what is pressure? Pressure is equal to force per area. Okay, force per area. Here, so P is equal to F1. Here F1 pressure is F1 force is applied. Okay, so F1 by A1. Here the large area you are considered the large area. P is equal to F2 by A2. P is equal to F1 by A1. Here P is equal to F2 by A2. Now you equate P equal to P. So P is equal to F1 by A1. Here P is equal to F2 by A2. So F1 by A1 equal to F2 by A2. Now you write F1 by A1 is equal to F2 by A2. Now the left hand side and right hand side now you change. So F2 by A2 equal to F1 by A1. So what do you find out? F2. So F2 equal to F1 by A1 into A2, cross multiply. So F1 by A1 into A2. Now the area only you are considered in one side. So F1 multiply A2 by A1. Now you consider the value A2 by A1 is greater than 1. F2 is greater than 1. Okay. So A2 by A1 value is greater than 1. F2 is greater than F1. Here the hydraulic system is otherwise called force multipliers. Okay. Number 4. A hydraulic system is used to lift a 2000 kg. Lift a 2000 kg vehicle. So the mass is 2000 kg in an auto car. If the vehicle sits on a piston of area is equal to 0.5 meters square and a force is applied to the piston of area 0.03. Now here listen, 0.5 meters square, here 0.03 meters square. What is the minimum force that must be applied to lift the vehicle. So what do you find out? F2 is find out. Okay. So F1 already given. So given A1, area of the cross section A1 is equal to 0.5 meter square. What's the formula? F is equal to ma. Force is equal to mass into acceleration. So the weight of the vehicle F1 is equal to how much? M. Mass value is 2000 kg into acceleration due to gravity 9.8 meter second power minus 2. Okay. So A2 value is A2 is equal to 0.03 meter square. So what do you find out? F2. Now you apply the formula. P1 is equal to P2. P is equal to F by A. So F by A1 is equal to F2 by A2. F1 by A1 is equal to F2 by A2. Now you are considered F2. F2 is equal to cross multiply. So F1 by A1 into A2. Okay. F1 is value, force is equal to how much? 2000 into 9.8 divided by A1 is 0.5 into A2 is 0.03. Okay, now you calculate all the values, you get it the answer 1176 Newton. Okay. Students, now we are going to learn about density. What is density? Density is equal to mass per volume. Now you take two identical flasks. One is filled with water and another one is filled with kerosene. So now you mark the water level 250 ml. Okay, and mark the kerosene level is 250 ml or 250 centimeter cube or 250 centimeter cube, because 1 centimeter cube is equal to 1 ml. 1 centimeter cube is equal to 1 ml. Okay. Now measure the balance. So we use the digital balance. Now you calculate the mass. Okay. Now what do you understand here? The flask filled with water is heavier than the flask filled with kerosene. Okay. Flask filled with water is heavier than the flask filled with kerosene. So, now you calculate the unit volume of water and unit volume of kerosene. Let us assume the mass of the flask is 80 gram. The mass of the flask is 80 gram. Okay. Here, the mass of the flask filled with water is equal to 330 gram. So, the mass of the flask filled with kerosene is equal to 280 here. 280, mass of the flask filled with water is 330 gram. Okay. So the mass of the water is equal to, here how much? 330 gram. Mass of the flask is equal to 80 gram. So 330 minus 80 gram equal to 250 gram. Okay. So the mass of, now you are calculate the mass of kerosene. Mass of the kerosene totally 280 gram minus mass of the flask is equal to 80 gram. So 280 gram minus 80 gram is equal to 200 gram. Okay. So the mass per unit volume of water. Mass per unit volume of water. Here listen, 250 gram. So mass per unit volume of water 250 gram divided by 250 centimeter cube. Okay, equal to, now you cancel 1 gram per centimeter cube. So 1 gram centimeter power minus 3. We calculate the mass per unit volume of kerosene. So mass per unit volume of kerosene. Here the mass of the kerosene is 200 gram. Here mass of the water is 250 divided by 250 centimeter cube, or here mass of kerosene. Mass of kerosene is equal to 200 gram. So 200 divided by 250 centimeter cube. Okay. Now you cancel it. We are getting the answer 4 by 5 gram per centimeter cube. Now you calculate the value 0.8 gram per centimeter cube. Okay. SI unit of density is equal to SI unit of density. Density is equal to kilogram per meter cube. The symbol of density is rho. How did you write? Rho. Okay.